if I have a plus bi, and then what is the conjugate of a plus bi? I can say that is just slightly change the sign, so a minus bi. They are conjugate relationships, so they are complex conjugates. Okay. So we're learning the new vocabulary today. So we're talking about conjugate. So to make it easier, so we can just say if you have complex number a plus bi, let me call it z to make it shorter, then a minus b, which is the conjugate, can be written as z, and then asterisk. You know, it's in your phone you have like this hashtag and asterisk, so you choose this asterisk on top of your z upper right corner, and then we are going to call it conjugate of z. Okay, is it okay?
Yes.
Yes. Okay, so what do we also have to note is that you can make the denominator real by multiplying your complex numbers, complex conjugate, both to top and bottom. So what I mean, so make your denominator. Denominator means just the bottom in your fraction. Denominator, real. What do I mean? So for instance, if I have 3 over 3 minus I, I don't like it because my bottom is conjugate numbers. I always want to have something real on the bottom. So what I am going to do, using conjugate, not using, let's be more specific, by multiplying conjugate complex. Okay, so the conjugate of 3 minus I is 3 plus I. So when you multiply conjugate, on top and bottom both, you have 9 plus I squared is negative 1. So it's just a 1, like negative times negative, and then 9 plus 3i. So what you have is 9 plus 3i over 10. So now you made the bottom real number. 10 is real number. So that's how you use it. So let's talk about the process of thinking. Why do we need it, and then where it's coming from? So let's make a connection to quadratic formula and its roots. So quadratic formula is used to find solutions for quadratic numbers. So let's make an observation in real coefficients. So let's say when delta is greater than 0 in ax squared plus bx plus c is 0, this is a quadratic equation. Delta is discriminant. If you remember, discriminant is a b squared minus 4ac in your quadratic formula. It decides if it's going to be real roots or complex roots. When this happens, if c plus d square root of n is a root, then it's conjugate, which means c minus d square root of n is also a root. Sorry, let's see. A root. Okay, so why? It's because quadratic formula looks like that. It's minus b plus minus b minus, and then rest of the parts are the same. So your discriminant delta is b squared minus 4ac, and then divided by all by 2a, right? So they're gonna just have a different sign right here. So that's why when you have a quadratic equation, and then if you have one root with positive sign in between, another root is going to be its conjugate. So it can be, this is observation you already made, it maybe mean in middle school or even like 9th or 10th grade. So what we're going to do is we're going to take a little bit further to make a second observation. So what's going to happen when delta is less than 0? Do we have real roots, guys, here? What's going to happen with the solutions of quadratic equations? What happens if your delta, which is b squared minus 4ac, is less than 0? What happens? Vicky, what happens? Can you say undefined, right? Undefined in real number system. So the answers is going to be not real numbers, complex numbers, right? So all the same condition, but delta is less than 0. Then now you have complex roots. So please remember, this gives you complex roots. When you have complex roots, let me write it down something like a plus bi. if a plus bi is a complex root, then another one, a minus bi, is also a root. Same reason, because we have negative b plus minus delta, square root of delta, right? Let's make the third observation. The real discussion that I wanted to make is actually number 3. Number 1 and 2 is kind of reviewed from what you know. So what I want to do is explore with the sum of x1 and x2. Well, x1 plus x2 is coming from, so basically x1 plus x2 is coming from simply take the first one and then add the second one, right? So what happens here? We can cancel these out, right? And then what do you have left over? It's going to be negative 2b divided by 2a, which can be simplified negative b over a. Do you agree? Is it okay?
Yes.
Okay, thank you for answering. Okay, now I want to talk about product of x1 and x. So you have two roots in quadratic equations, and then you multiply them, x1 times x2. And let's see what happens. You have negative b squared minus b squared minus 4ac, square root, but it's squared, right? And then what happens, bottom is going to be 4a squared. You can, okay, maybe it will be cleaner if I just separate it and then combine them later. Okay? Let's make it more efficient, sorry. I think that you can do this in your head, that we combine all together at once, and then you can reach the conclusion that it's going to be b squared minus b squared plus 4ac, everything divided by 4a squared, which means you get rid of it because that's a 0, and then you get rid of a on top and then 1a. So 4c divided by 4a, so 4 there cancelled, so it's going to be c over a. Right, so what you're trying to achieve is that, okay, how about remember this number pattern, and then what we're going to do from now on is try to see where you can find those. Where do you have a and b? What do they mean? Where you can find the c? Let's observe this. A times x squared plus bx plus c is 0, and then what I'm going to do is take a outside and then suck a outside of the parenthesis. Then what happens here in the middle? B over a, and then c over a. Aha. So this baby is right here. They are the same number, right? Of course, you have different sign. It's a negative a, and then this is plus a, but it's a similar enough. Okay, so observation 3. This is the essential information that I'm trying to make. So because of these observations we made, now we can reach to a conclusion. I'm going to make it a little bit thicker because it's very important. Theorem. So what am I trying to achieve today is that the rule, if c plus di is one root, and then the conjugate of c plus di is also another root, are roots of a quadratic equation. If they are roots, right, then the quadratic equation is a x squared plus something x plus something. Okay, now we have to figure out what's that something in the parenthesis. Okay, c plus di plus c minus di is the sum. The sum goes here, minus sum. So we have to figure out what minus sum is. 2c, right? So what I'm going to put here is negative 2c. Okay, what is the product of two roots? C squared plus d squared. So what I'm going to put here is c squared plus d squared. Okay, this is the theorem that I'm trying to make. So, I mean, the bottom is my calculation. What's essential today, you forget everything from today, but this theorem is the essential takeaways you have to achieve. Okay, now please answer me. So far, so good?
Yes.
Okay. Seems like Julie has some problem with her computer. Julie, are you okay? I will record this and then post and manage back, so don't worry about it. All right, so let's move on. For example, are you taking notes, guys?
Yes.
Okay. Example 1. I want you to find all the quadratic equations with real coefficient if they have a root of 1 minus 2i. So find quadratic equation if 1 minus 2i is a root. Okay, so if I have 1 minus 2i as complex root, what's another possible root, guys? We just talked about it in the theorem. x1 is
1 plus 2i.
very good. So now what I'm going to do. Before, if you didn't know the theorem, what you might have done is you just set two different trinomials and then you expand, right? It takes too much time. So we might not do it. So now I have a better method. Okay, so what is x1 plus x2? I want to get sum.
x1 plus x2. 2 plus. Let me write it down.
I wrote it down right here. 1 minus 2i plus 1 plus 2i.
2.
Very good. Vicky, what is x1 times x2?
5.
Oh, very good. Thank you very much. 5. So what you can do now, use the theorem. So what I'm going to do is plug this in. X squared plus something, which is negative sum of the two roots. And then in this parenthesis, you have to have the product, right? So what I'm going to do is plug this one right here, 5, and then sum is going to be negative 2. So is it okay? So what can you say about A? Do you know what A is here?
Yes.
What is A here?
You know A.
But right here, if you expand here, you can kind of guess.
X. Right.
Right, I'm not going to expand all, but you know that it's like what x squared is the leading, and then it's blah, 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 right? So you know that it's going to be only 1. So I will just free this baby and then leave it as x squared minus 2x plus 5. So now you found the quadratic equation. But technically, if you don't consider it, you can just leave it as A. If you didn't try the expansion, then you can just leave it A. That's also the correct answer. Yeah. So let's take another example. Find exact values of A and B if square root of 2i is a root. X squared plus ax plus b is 0. Okay, remember A and B, it's all real numbers, not complex numbers. So now let's talk about the sum. Vicky, what is x plus a1 plus x1 plus x2? Makes it
2 square root 2.
very good. You just wrote you just said the answer. 2 square root of 2. Very good. Voran, what is this product? You can do it in your head.
3.
You said 3, very good. So now only thing you have to do is think about it. So it's already given that your leading coefficient is 1. There's 1 multiplied here, so it's omitted, right? So A is going to be minus 2 square root of 2, and then B is going to be 3.